Hi my friends. Today we have a very interesting tutorial with dynamic simulation. We have some components to create this pendulum, and then we apply the dynamic simulation tool, and we study what is the dynamic of this pendulum. Here you see a trajectory. Yes, it starts from here when this cylinder was here, and then you see a movement of the pendulum, very natural and realistic. You will see how to download the components right now. Using that components, we can create an assembly. Let's do it. New assembly, place, stand, place grounded at origin, escape, and then space, axle, escape, space, axle. Two axles are here, pendulum double and pendulum single. That's all. Yes, we start by constraining these objects very rapidly. You know procedures. I use this solution and I go back the stand to place it here. Apply. Then I move the solution because I insert this here. Apply. Then this single pendulum here. Apply, and then with that solution the short axle placed here. That's all. We created the pendulum. The pendulum is very flexible, and you see that it doesn't collide with anything here. That's very great, because we don't want to have collisions. Yes, look, there is a space between all parts. Good. Now we know how is this constructed. I'll place it in a position like before, somehow, and then I activate the dynamic simulation. I make this by activating environments and the tool dynamic simulation. You see here a very important dialog box. You have here everything, as you will see immediately. The first thing I try is to apply play. If I do this, nothing, absolutely nothing happens. Oh, why? Because there is no forces here to put this mobile object, the pendulum, in movement. Let's place the gravity. Yes, I go to construction mode. You see here is blocked all the access to the browser, but when I click here I have access, and I can go here, double click on gravity, which is an external load, as you can see, and I have two possibilities: either to choose an entity or vector components. Here there is an entity. This is the entity which is vertical for us. Yes, if I place this so, this is not vertical, but we know together that this is the position of the pendulum, but the direction is wrong, so I have to change it. Okay, if you don't like this arrow, you click here and the arrow is disappeared. Now I run again and something happens, you see? Good. And the cursor is moved from here to here. What is this? Seconds. Only 1 second was provided here. I change it to 10 seconds of our life. 10 seconds of our life will be consumed with this thing. Construction again, and oh, this is a movement. If I try to move in another position, this, I'll feel a resistance. Yes, something like a spring. Look, you have to do this to see what happens. Now we are assisted by the dynamic simulation module in Inventor. This is why we feel something. I change, this is the number of images from 1000 to 5000. And now when I start the movement, we see something like in slow motion. Yes, very natural, be sure. When you look to a movie, you see natural and unnatural things. A car was rolling on the street, but the rolling was not so natural as you feel. Good. I can stop it anytime, and I want to have a trajectory here. I go back to the initial position. I move this some, but only if I activate construction mode. I move it in this position, more interesting, and I go to trace. I choose the color. The color is this of the trajectory, yes, and the origin. The program waits for me to show the origin. I can show this or this, yes, parts which moves. which move. I choose this. You see now a bubble here. Yes, it stands for look, I'll make the trajectory. Okay, now the bubble disappears, and I go to the running, and the running is, of course, interesting. Okay, now if we want to see more and some details of this simulation, we can activate output grapher. This is the output grapher. Let me place somewhere to be visible. We can erase this trace by selecting from the output grapher and with delete. Then we can add a new trace. Let it be the same color, okay, but also velocity to have a graph. The velocity will be red and the trajectory will be orange. Also acceleration, why not? Of what point? The same point, this. Okay. Now, because the program has memorized all the situation from the second 0 to the second 2.6, this is already presented here. If I choose to see the velocity as a resultant vector and not by its components, and also acceleration as a vector, we have here all the graph. Yes, we can continue the running, and the graph is adding here. We can stop it anytime from here, from the simulation player, and then we can go back to study every moment. Let's modify the dialog box and graphic box, and let's double click here somewhere, and now you see every fraction of second to the third decimal of every point. I made here double click, I stay here, the focus is on this space, and now I use the arrows on the keyboard to go forward and backward. Forward is this, backward is this. If I keep pressing the left arrow, you see that I have control, and I see every moment. For instance, I want to see the moment when this is at the top. Which graph is this? This is the graph of acceleration. Look here, trace is blue and acceleration is red. I double click somewhere here and I use the key to the right, arrow key to the right, until I reach the top acceleration. it seems to be this. No, 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 not yet, not yet. You see here, yes? You see here that this is not, very very easy to lose the position. And we go to here. This is the moment, not this, but this one. You see, 1, 3, 1, 1, 3, 2, 1, 3, 3. This is the maximum acceleration. When the pendulum is here, this is the maximum acceleration. And where is the maximum speed or velocity? This is the speed. Yes, double click here, and I make the same research by moving the pendulum to be at the maximum velocity. I'm over the maximum because this is the maximum. What I want you to know? I want you to know that we have the full control of everything. If we enlarge this, we have a great picture over the screen. Yes, I make this to be in the screen for you, and you can control everything. 10 seconds means but I have no information here. Yes, I give this back and I continue to gather information from the dynamic simulation. Yes, I have to wait till the end to have all the information. Now all we have is what you see here. When it reaches the end, it stops. Stop. And now I have to continue because this is the range with the information. From here we have no information, and I click the play, and the information is also memorized, and we have everything here. You can consider this a game and you make everything you want. Let's go further. Further is to finish this simulation. Yes, and add another pendulum here. I saved the assembly, and now I create a new one where I place the saved pendulum. This is place grounded at origin, and another one. Yes, two pendulums. One is grounded and the other is not fixed. Let's constrain this one to be in the line with the other. Constrain, flush, the bottom is to be the same. Apply. The face, frontal face, must be in line. Apply. And the distance between these two must be 400. the result is that this is not colliding with this. Yes. Now if I want to move this, I cannot do it. Oh, but they are with the freedom degrees free. Why I cannot move? Because I have to make both of them flexible. Yes? When I make the first one flexible, I can move it. The other I cannot. And you can see here a mark about this. Control Z to be the same. And now flexible also the other. Now both of them are movable. You don't feel any resistance of any kind because we are not in the environment's dynamic simulation. Control Z, Control Z, Control Z. I want them to be in the initial position. Environments, dynamic simulation, gravity, double click, direction. Now we are expert in this matter. Yes? Okay. Click here to disappear the arrow. And now we start with 3 seconds. We start the movement. We see the same movement mathematically because they are made used by a computer, and the computer doesn't know, doesn't have friction or other things. You'll see that we can add friction. I change here from if I click on construction mode, of course, not 300 but 100 and 1500 to have this slow motion. Yes? Okay. Now for you I add frictions to one pendulum but not to the other, and you will see the difference. How should I do this? I go to standard joints. As a theoretical matter, I have to inform you that the constraints from the assembly were replaced by standard joints. Yes, and there are 4. 1, 2. They are 1, 2, 3, 4. Yes, 1, 2, 3, 4. You can see, can identify them on the screen. Good. Let's see. Let's work to this. Yes. Right click and properties. This is a dialog box with great power. DOF, degrees of freedom, is only 1. Rotation. Yes, here is only 1 degree of freedom. Rotation. Good. I go to edit joint torque. I enable this joint torque, which means I want to apply a torque. Yes. Dry friction is here. Dry friction, you know what is. Yes. Let's think of 0.1. This is mu, yes, the coefficient of friction. In mechanics, this is known. Where is this applied? This is applied at the circumference of this axle. We know that diameter is 12. If this is 12, then the radius is 12 divided by 2. Okay, for the moment. We make this to disappear by clicking on the name of the assembly. Then I start the running. Second by second, fraction of second, you see the difference. Yes, you saw it. You can apply the same friction in this joint, in this joint, in all 4 joints. I let this one to be applied for us to know. I have no time to make all the experiences. Okay, now I am interested to see what about collision. I go to construction mode, I take this and I try to make a collision between this and this. Oh, what is this? You see, they are passing one through the other. To apply collision, we have to create a new joint. A joint of collision. We do this by inserting a joint. Yes, you see here a tool. We have to choose from a lot of possibilities between 2 components which will be selected by us, and here is a planar, a 2D situation, not 3D situation. Yes, all of them are in the same plane. This is interesting because it simplifies our job. Here we choose 2D contact. This is 2D contact. I choose this circle and this circle. Okay, and now I try to see what happens. You see what happens, but this is not very okay because these 2 circles are colliding. Yes, this problem will be solved in my next tutorial. For now, I think that is enough. Bye bye.